Hi, I am preparing this video to help students understand basic concepts of physics. The idea is to make the subject look as easy as possible by incorporating some practical examples. Also, I have seen solving problems helps us to understand things better. So, at the end of each of the theory sessions, I shall try to solve few problems ranging from simple to very complex. It would be of great help to me if you can send your feedback so that I can further improve these lectures. To start with, I thought of starting with Newton's laws of motion, which are the pillars of classical mechanics. So let's straight away go into today's class, what is Newton's first law. So as you can see, we have described the Newton's first law, which states that a body continues in its state of rest or of uniform motion in a straight line unless acted upon by an unbalanced force. So the law is pretty simple. It states that a body will be in its state of rest or of motion unless an external force causes to change that state of rest or of motion. So in this law, let's first understand what do we mean by state of rest or state of motion. So the basic question is, how do we judge whether a body is in motion or rest? So we judge the rest or motion of a body by looking at its surroundings. So let's take an example. You say the sofa at your home is at rest because it really doesn't change its place with respect to the walls of the room. So every day you find the sofa in the same place. Similarly, so you call it at rest. Now let's take an example of a body which is in motion. Let's take a moving car. So why do we call it is in motion? Because every second it changes its position with respect to its surroundings. So the first second it's near you, the very other second it moves away from you. So you say that the car is moving. So we judge motion. Our common sense tells what is motion or what is rest. It's with respect to its surroundings. So let's take an interesting example now. In this example, we have a cart, and this cart is moving with a uniform velocity v. Inside the cart, we have an observer whom we named as observer 1. So let's assume that the walls of the cart are opaque. So the observer 1 is not able to see the outside world sitting inside the cart. To him, he will not be able to judge even whether the cart is in rest or whether the cart is moving or not. Now, so this observer 1 has a table in front of him, on top of which there is a book. So what is the observation of the observer 1 with respect to the book? So the observer 1 will say that the book is in rest, because to him the book is not changing its place with respect to the surroundings being the inside of the cart for this observer 1. Now let's have another observer whom we call as observer 2, and this guy is sitting outside the cart. So now let's make another contradictory assumption. So for observer 1 we had assumed that the walls were opaque. So now let's assume that the walls are transparent. So this guy can see the table sitting outside from the outside. So what will be his observation for the book? Since the cart is in motion, he will say that the book is in motion because it's changing its place. So you see, to observer 1, the book was at rest. To observer 2, the book is in motion. So, which is correct? The question lies. And how is Newton's first law satisfied? Because one observer says that it's in rest, whether the other observer says it's in motion. So, understanding motion and rest is very critical here. So, as we see, the observation for both the observers are correct. Motion and rest are relative terms. What might be in motion for one observer might be at rest for another observer. So it depends how we are judging rest or motion. So as I was telling you that we are judge the rest or motion with respect to its surrounding. So this surrounding object with the respect to which we judge the motion or rest, we call it as the frame of reference. So we have a reference frame, and with respect to that reference frame we really judge whether a body is moving or not. So as long as these references frames are non-accelerating or moving with a constant velocity, these are called inertial frame of reference. That's what is given in the next slide. So inertial frame of reference, now you understood. So both this frame of reference, one was inside the cart was moving with a uniform velocity v, whereas the other one was the outside world. So both these are inertial frame of reference, and whatever observation you make from an inertial frame of reference will always satisfy Newton's law. So basically Newton's law will be satisfied for observer 1, Newton's law will be satisfied for observer 2. So what did we understand? We understood what is rest, what is motion, we understood what is frame of reference, and we also understand Newton's first law now, that is every body continues to be in its state of rest or of uniform motion in a straight line unless acted upon by an unbalanced force to change that state. So from this first law, two very important concepts are deduced. One is inertia of a body and the other is definition of a force. So let's understand what do we mean by inertia of a body. The inertia of a body is defined as that property of it which tends to resist a change in its state of rest or of motion. So as Newton's first law states that every body continues in its state of rest or of motion. So basically there is a tendency to continue in that state itself. So this tendency is called the inertia. However, if you apply force, this state will change. So if a ball is at rest, it will continue to be in rest forever unless you apply a force in the ball. So the moment you apply a force in the ball, the state of the ball will change from rest to motion. So this tendency to resist, so whenever you apply a force on the ball first tends to resist the change of state from rest to motion. So this tendency is called inertia. So this is directly linked to the mass of the body. So higher the mass, higher the inertia. In other words, if we have two identical balls, say one is of rubber whether the other one is of lead, the one which is of rubber will have a lower inertia, or the amount of force required to change its state from rest or motion or from motion to rest will be lesser as compared to the lead ball which has higher inertia. So we understood now what is inertia, and this inertia is directly linked to the mass of a body. Also we defined what is mass. Mass is defined as the quantity measurement of inertia. And as I told you, there is another concept from this law itself, the definition of force comes out. Though there are various ways by which we define force. So one of the way by which we define force is that physical quantity which changes or tends to change the state of rest or of uniform motion of a body. So the state of rest or motion changes when you apply a force. So force is that thing which causes to change this state from rest or motion, or rest to motion, or motion to rest. So hope you all understood Newton's first law along with what is an inertia. We also understood what is force. We also understood frames of reference and what are inertial frames of reference. Next is a simple experiment which demonstrates about inertia. So in this example, we have a cart. As you can see in the cart, and there's a two lead balls which are mounted on the cart, and those lead balls can move, rotate in either of the direction. So suddenly you apply force on the cart and the cart starts moving on towards your left. So what will happen to the lead balls? Since the lead balls are of course identical in mass, both are exactly equal, everything is identical. So in this case, though the cart starts moving towards the left, the ball remains as it is. In the next example, what we did is we changed one of the lead balls with a wooden ball. So as I told you, of course the wooden ball will have lesser mass, which means it will have lesser inertia as compared to the lead ball. So the moment the cart starts moving towards the left, the wooden ball having lesser inertia will go to motion first as compared to the lead ball. So this will result in an anti-clockwise movement of the two balls. Hope you all were able to understand in today's session what is Newton's first law along with inertia. If you have any questions, please feel free to ask me. In the next class we will cover Newton's second law, third law, and in subsequently we will try to solve few problems using these laws. Thank you.